Just give me a second. Just a second. Yeah, I have started the live streaming. I have kept the link in the chat box as well as in the calendar. So this week we'll be discussing about second. Yeah. Okay, this week we'll be discussing about week 10 9 sorry week 11 and week 12 for revision. So is my screen visible?
Yes, ma'am.
So we are in the revision session 2. So this will be the last session in this term for signals and systems. What has been discussed? So mostly in the week 11 and week 12 Laplace transform and inverse Laplace transform like standard signals and their properties were discussed. So I'll be quickly going through them and we'll be solving the problems as well. So Laplace transform. So we are evolving. This comes from the Fourier transform. Like so, we came into this concept uh, uh, because Fourier transform is not applicable for infinite infinite energy signals, right? So we will be in such cases we will be going with the Laplace transform. So it is mostly used in the case of aperiodic and infinite energy signals. That means for Fourier transform, it is for a periodic signal, but the signal need to be stable. I mean, the signals should have finite energy. So we will be converting the Fourier transform. Usually Fourier transform is written as x of j omega integral of integral from minus infinity to plus infinity x of t e power minus j omega t into dt, right? So if the signal is in this way, if the signal is in this region, so we want to make it decay. I mean, so we'll be multiplying the signal with some e power minus t constant. I mean, with this thing, we'll be multiplying. So it will be so x of s will be integral of minus infinity to infinity x of t e power minus st dt. So where s is sigma plus j omega. So it is not purely an imaginary. S is not a pure. It is not pure imaginary one. So inverse Laplace transform formula is, I mean, like here we will be multiplying x of t with this constant. As a result, we will be getting as integral of minus infinity to infinity x of t into e power minus sigma t plus e power minus j omega t dt. So if we common out minus and t, will be left out with this. So in that case, will be I represented as this whole expression in terms of this. So inverse Laplace transform formula is, so x of t is equal to 1 by 2 pi j integral sigma minus j infinity to sigma plus j infinity capital X of s e power st ds. So, like till here, you are clear, right? Hello.
Yes, ma'am.
Yes, ma'am. Clear, ma'am.
Yeah. Okay. So, like we'll be having question like, is Laplace transform? Does it exist for entire region or what? So, in order to define that, ROC comes into picture. So, ROC is region of convergence. Region of convergence, ROC. So, what it tells like in what region the Laplace transform will come to a point, like when in what region Laplace transform will be in a finite. That is what region of convergence is. So where the Laplace transform, this is a region where the Laplace transform exists and absolutely integrable. ROC is. And one more point I wanted to add in the previous slide is, since it is we are dealing with e power st, which is not a, these are not orthogonal. Like till like Fourier transform, we are dealing with the orthogonal, right? But here orthogonality doesn't satisfy because of we are adding this e power minus sigma t. Orthogonality does not satisfy. As a result, we won't be having Parseval's theorem, and energy theorem doesn't satisfy in this case. Parseval's theorem and energy theorem will not satisfy in for Laplace transform. So we were talking about region of convergence. So like so region of convergence will be entire S-plane. There are like few cases in this. One is when the region of convergence for finite signal. So if the signal is finite, then the region of convergence will be entire S-plane. So for if we take delta signal, so this is a finite signal, right? I mean, this is existing at a point that is at t is equal to 0. This is not an infinite signal. Like finite signal means it exists in a finite duration. So it is existing in the finite duration. So the if we plot, so the region of convergence will be entire S plane. So where x-axis, this is a Laplace transform plane. So it is S plane. So x-axis is a real axis which is sigma. and y-axis is the imaginary axis, which is j omega. And another case is for the right sided signal. So for right sided signal, uh, if the signal, for example, if we take the signal in this way, so this is right sided signal, right, in the time domain. So ROC will be also in the right side. It will be like this. ROC also will be the right sided. So whichever area I'm shading, it is where the Laplace transform will be satisfied. Clear?
Yes, ma'am.
Okay. And for the left sided signals, consider a signal which is like left sided. For example, we'll take this signal. So this is left sided, right? So for this, the region of convergence will be the left sided. Like I'm taking the, like this is how like it looks like. And if we take two sided signal, for example, like e power this signal, so it is two sided, right? So for this, in this case, it will be like a strip. This is how it be. It will be between two poles. So I'll be discussing what is this pole and what is this zero in the further topic. So like ROC will be like this. So now I'll be discussing about the pole zero plot. So one more thing I would like to tell is like h of t is impulse response of a system. H of s will be the transfer function. So like if we or like what to say. So usually this for suppose if h of s is represented by some numerator polynomial n of s by the denominator polynomial which is h of s. If it is represented in this way, so zeros are roots of numerator polynomial and poles are roots of denominator polynomial. Because for suppose for n of s is represented as, we'll take a1, s minus a1, s minus a2, etc. by s minus b1, s minus b2, etc. and so on till this is till s minus am into this by s minus bn. So the roots will be roots of the numerator will be a1, a2, and so on till am, right? And roots of the denominator will be b1, b2 till bn. So when we substitute these values, so if I substitute for suppose a1 here, so entire polynomial will be getting 0. That's why it is 0. And if we substitute b1 in the denominator here, so it will be 1 by 0, which will be getting into infinity. So like it will be like this, like it will be approaching to the infinity, right? So that is the reason it is poles. So zeros, like in the S plane, it will be represented as 0 only. I'll be explaining the problems, like one of the problem regarding this. And poles will be represented as into mark. This is clear, right?
Yes, ma'am.
Okay. So like the number of poles, it is a degree of the denominator polynomial. Like in order to know how many poles are exist, it is a degree of the denominator polynomial. That is denominator polynomial is d of s, and number of zeros is degree of the numerator polynomial n of s. And like for rational Laplace transform, so this is a Laplace transform of h of t, right? Like for rational Laplace transform, uh so like how we will be considering the region of convergence? This is a question. Like if there are, so there are many poles and zeros, right? So we will be for ROC we'll be mostly focusing on the poles. For ROC, our main focus will be on the poles. So based on this, region of convergence will be depending. And if so, we have to make sure that if we find some ROC, like for suppose there are many poles are there. For suppose if it is a right-sided signal, means the region of convergence should be right-sided, right? So it has to be the rightmost of that. For right-sided signal, it should not include other poles. Like this should be the pole need to be the rightmost. Did you get this? Any doubt here? For right-sided, we will be having the ROC as right-sided, right? For the right-sided signals. So like it has to be, there are many poles, like it can exist here, it can exist here. But why I am choosing here is it has to be the rightmost. Like that is like it should not include other poles in the region of convergence. This is what it means. For left-sided signals, for left-sided signal, the region of convergence will be right-sided, right? Sorry, left-sided, right? So if we consider the poles like this, it has to be like, it should not include, like region of convergence could be this, like we can consider this for, but for the left-sided, ROC need to be left side, right? If, so it should not, the condition is it should not include any of the poles in the region of convergence. If I take here, for suppose here, so it will be including this thing. So this part and this part should not be considered. Only will be considering left of the leftmost pole for the region of convergence. And for suppose for the two-sided signal, two-sided signal, So it has to be ROC will be like a strip, right? It should be leftmost and the rightmost pole. So it will be usually for two-sided, it will be like a rectangular strip. So it has to be like leftmost and rightmost region. This is how like it be. We have to choose the region of convergence. Is this clear? This point?
Yes, ma'am. Yes, ma'am. Clear.
Okay. Soon, like we will be discussing about the how the frequency gets affected. So if we take the S plane like this, and frequencies will be there, right? So if we take here this region compared to this is a pole. So the region, I mean the so if the frequency is far away from the pole, then it will be attenuated. The frequency gets attenuated. Like if it is far away from the pole, means that is frequencies far away from the pole gets attenuated. And the frequencies near to the zeros, it also gets attenuated because we have seen like x of s, which is a which will be having numerator and denominator polynomial. So if we for suppose like in the last slide I have told like this could be expression like s minus a1, s minus a2, s minus am, s minus b1, s minus b2, and so on till s minus bn. So if the frequencies, so this part, if it is nearer means, so which if it is like 2, so it is something will take near to this is 2.2, so it is 0.2, so which will be making this as like some 0.2, like very small, right? So this part, this will be reducing, right? If it is very less, the difference will be reduced and it will be making it to reduce. If we take very far away from the pole, like if we take it is 3, oh, okay, we'll take 2 only number, and very far means something around 100 will take. The difference is like 98, right? So it is 1 by 98. So it will be it is also decreasing, like which is far away from the pole also it is decreasing the value, right? The frequency will be attenuated. Like this is how you have to remember this point. And the reverse case, like frequencies which are near to the pole, frequencies near to the pole, it will allow. And frequencies away from zero, also be allowed. Now I'll be discussing about the Bode plot. So Bode plot, uh, do anyone want to tell something or any doubt till here?
Ma'am, which other frequency will be cut off then?
I mean like if you take some point over here, okay. So I was taking points here, okay. These 2 points I'm considering. This is a pole,
Okay.
right? I
Yes,
mean
ma'am.
like the point which is very near to which is, I mean these are the frequencies, right? Like frequencies will be like s means like it is sigma plus j omega, like Omega, what is omega? Omega is frequency only, right? Angular frequency.
Yes, ma'am.
Like if we take the points which are closer to the pole,
Okay.
will be allowing the frequencies, okay? I mean, this will be allowed. This point is very near to the pole, right? This
Yes,
frequency
ma'am.
will be allowed. And the far away from this will be attenuated. Did you get this?
Attenuated
This is a
means?
point. Attenuated means it will stop.
Okay, ma'am.
Like similar, okay, we will take some point over here. I mean, like, so it is very far. I mean, compared to this. So the chance of allowing this is okay. Like, it will be mostly attenuated. It will be little bit attenuated. Did you get
Okay.
this?
Yes,
Like
ma'am.
in the similar case, if we take zeros, if I take 0 over here, so these are very, I mean, these are very far, right? So this will be allowed.
Yes, ma'am.
You got my point now?
Yeah.
So this will be this will be mostly allowed in case. Okay, I'll draw with another color. So for 0, this will be mostly allowed. This will be not that much allowed since it is near to the 0.
Okay, ma'am.
That's what I was telling. Any more doubts? Others? Okay then. So Bode plot, like it is a plot of magnitude of a system. It is a plot of magnitude of a system. So like how the for Bode plot, x-axis will be omega and y-axis will be h of s, because it is a magnitude, right? Magnitude of the system. So like x-axis will be in the log scale, whereas y-axis will be in the decibel. Like few important points over here you have to notice. If there are zeros, it will be incremented by 3 dB. If there are poles, it will be decremented by 3 dB. And per every decade, like there will be change in 20 dB. These are the important points you have to remember. Like this I have told in one of the lecture. I mean, like one of the one of the session I was discussing about the designing of this. So you can refer that video. Like if you want, I can tell in a rough way. Like so, like if we take some, okay, 0 here, like so, like let's say it is 0 dB here. Here is a point. So here, if it is 0, so when it comes to this point, it will be increased by 3 dB here. So it will be 3 dB and it will be keep on increasing until if it hits like another 0 means it will be increased by again 3 dB here. I mean, at here it will be increased by one more 3 dB and it will be increasing. So if there is for suppose if there is what to say, if there is pole, when it hits the pole it will be decreased by 3 dB, so it will be decreasing. Did you get this? this is a pole, right? So it will be decreasing by 3 dB and it will be continuingly decreasing. Uh, did you get clarified here? Hello? Can anyone respond? Hello?
Yes,
Yes,
ma'am.
ma'am. You are-
Yeah. Can I go further then ahead? Next concept.
Yes, ma'am.
Yeah, for more detail, you can check the that lecture or uh, lecture which was taught regarding this Bode plot. It was explained very detailedly. So now I will be discussing about properties of Laplace transform. Properties, like as usual, like how we are seeing for this, we were seeing from Fourier series for Fourier transform, right? How the signal gets affected when it is conjugated, or when it is reversed, or when it is undergoes time shifting. Like those properties only we'll be discussing over here. So here let it be x of t, and this be in the Laplace domain, which is x of s, ROC, and poles and zeros. How will be the pole sign, how the ROC gets affected, and how the poles and zeros get affected. So if we conjugate a signal, okay, if we conjugate a signal, this is like usually in the Fourier transform, it will be like x star of minus j omega, right? But here it will be like x star of s star. Like this is how Fourier transform be, and there will be the no change in ROC, because like it I mean, like it will be flipped along x-axis. So there will be the no change in ROC, and poles and zeros will be conjugated. So like it will be flipped along
X-axis, right?
flipped along x-axis. That's the reason there is no change in ROC, but poles and zeros will be affected. If we take time reversal, so in the Laplace domain also it will be reversed. So it flips the direction along y-axis. Flips along. ROC will be also flipped along y-axis. Sign also gets changed here. Sign of the poles and zeros will be changed as it is flipping along y-axis. So the other property is linearity property. So which will be following the superposition property, and linearity and homogeneity property. So it will be in the Laplace domain, it will be ax1 of s plus bx2 of s. So region of convergence will be, so for suppose region of convergence for x1 of t is R1, and region of convergence for x2 of t is R2. So it will be the intersection of both the regions will be taking. So unless it is so this holds true, unless the if the resultant of this is finite, I mean, if the resultant of this in this is finite energy, then it will be entire S plane, right? So unless in that situation, so unless the sum is finite length, it, I mean, it is not satisfied when the sum is finite length. And zeros also changes. There will be change in zeros and poles will be P1 union P2. Next, time shifting. So I have discussed this like so if there is shift, if it is negative over here means in the Laplace domain, I mean in the Fourier domain, it will be also negative, right? Similarly, here also it will be negative JSV. If it is negative means here also negative. If it is positive means here will be getting positive for time shifting. So there will be no change of region of convergence and it will be not like, so it will be not a rational form like poles and zeros. So you have to remember this table. So if there is shift in frequency domain, so here it is as it is, right? Here it will be changed. Sign will be like here it will be positive. So it is e power vt into x of t. This is how it be. So ROC will be region of convergence of this plus we'll be adding with the real part of v. And the pole sign will be adding the same value to this v, this constant v will be adding to the poles, and for the zeros also will be adding. Like now let's see how it will be getting affected when it is scaled in time domain. So if it is scaled in time domain, so if it is compressed here means it will be expanded in the frequency domain. If it is expanded in the time domain means it will be compressed in the, I mean, it will happen in the reverse way. So it will be x of s by c with the constant c. This way, like Laplace transform b. So here region of convergence is scaled. So region of convergence will be CR. So ROC is scaled. So if C is, I mean, C is greater than 1. So if it is 3 here, it will be expanded, right? It will be compressed right here. So in the, here it is by C. So it will be by 3 means it will be expanded. So region of convergence will be expands. It expands here. And if it is less, means it gets compressed. Coming to the poles and zeros, it will be also scaled with the same factor. Like that is whatever constant we are scaling with, it will be done. Is this clear? Like all these properties are similar except this, right? It is similar to Fourier transform, right?
Ma'am, scaled poles and zeros means it is moving away from moving in the x-axis, right?
Yeah, it will be. I mean, so if it is for suppose if it is for original, it is -1. So if it is scaled by 2, means the pole in the scaled version. This is the original case. It will be x of s. So it will be scaled, right? So it will be
Means
scaled
minus
by,
2.
yeah, here, I mean, it will go to -2.
Yeah.
1 by 2 x of s by 2, right? So
Yes,
it
ma'am.
will be expanded, right? S by 2 means, here you see it is 2t, like it will be 2t which will be compressed. Here s by 2 it is coming. So it will be expanded by 2 times. So it will be -2. Did you get this?
Yes, ma'am. Okay, ma'am.
I mean, the point will be here. So that's why it will be going to -2. Since it is expanding, we are multiplying with constant. Clear, right?
Yes, ma'am. Clear, ma'am.
Okay. The other property is convolution property. So usually, if it is convolved in the time domain, it will be multiplied in the Laplace domain, right? I mean, it happens in the Fourier series as well as in the Fourier transform, right? In the similarly, if it is convolved, it will be multiplied. So time domain and S plane, which is a frequency domain. So it will be multiplied. So region of convergence will be like intersection of both the regions. So here also condition is, unless if the result is finite, like this holds true. Unless result is finite length. And the poles and zeros, it will be doing union for both cases. Like one more thing which I wanted to tell is, if we multiply in the time domain, here it doesn't exist because there will be no relationship here in the S plane, because it won't be convolved, because it is not satisfying the orthogonality, all those properties, like, so it won't be satisfied. Even uh, if we convolve here, we won't be having this as well. So this you have to remember, these two are different from Fourier transform. So I'll be discussing about some standard pairs. So standard pairs in Laplace transform. For delta of t, so okay, we'll be taking x of t and x of s. This is time domain and s plane. So for delta of t, it will be 1. Okay, and for constant, it will be c by s. So of t, it will be 1 by s. because there is one relation, right? If we do the integral, it will be divided by s, right? So if we do the integral for this, we'll be getting u of t, right? So we'll be getting 1 by s, where region of convergence will be real part of s greater than 0. If we take e power minus at ut, this it will be 1 by s plus a, where region of convergence will be real part of s is greater than minus a. And if we take this is a generalizing one which I am going to tell one, like t power, this is this also you have to remember, t power n minus 1 e power minus at ut, the Laplace transform will be n minus 1 factorial divided by s plus a whole to the power of n, and real part of s is greater than minus a. If we take cos signal, which is multiplied with u of t, it will be s by s square plus omega naught square, where real part of s is greater than 0. For sine signal, like instead of s, we'll be having omega naught here. Omega naught by s square plus omega naught square. So for cos, it will be s in the numerator. For the sine, it will be omega naught in the numerator. And region of convergence will be real part of s greater than 0. Clear? Like, hello?
Yes, ma'am.
I think one of the your classmates were asking, right? You wanted some formulas, like you can go through this, like properties and standard waves. Can I go ahead?
Ma'am, don't you have property like multiplication time domain equal to 1 by 2 pi times of convolution of frequency domain?
Oh, we are not having in the Laplace transform, because if you see, what to say, I mean, it will be converted to like x of t and y of t will be in single direction, right? I mean, it
Yes.
is 1D. If
Okay.
we take in the s plane, if we convolve it, I mean, like there will be the dimensional thing doesn't match. That is x of s convolved with y of s. So this is I mean, these are two dimensional, right? I mean, we are having a sigma and j omega axis here for S
Okay,
plane.
okay. So we need to
I mean,
convolve both the axes.
so like here it will be 2D, but here t is in one dimension, right?
Yes,
So
ma'am.
that's why we won't be having.
Okay, okay.
So we won't be have if for the if we multiply, we won't be having in the S plane, and if we do convolution here, we won't be having the corresponding t domain.
Okay, ma'am. For Fourier transform, it holds good, no?
Yeah, for Fourier transform it is there, but Laplace transform we won't be having.
Okay, ma'am.
Okay, okay.
Done.
Let me interrupt here a bit. Hello,
Okay, sir.
am I audible?
Yes, sir. Yes, sir,
Yeah.
you're audible.
So, Nanda, your question is convolution in frequency, no?
Yes, ma'am.
Yeah. So, it is actually there. So, there is a property. The same thing, but it will be 1 by 2 pi j. It's not single
Okay.
1 by 2 pi. It will be 1 by 2 pi j.
Even in Laplace, right?
Yeah. Laplace only I'm talking. So, if you have two signals,
Yes, sir.
like x1t and x2t, if you multiply in time domain,
Okay, sir.
then its corresponding Laplace transform will be 1 by 2 pi j
Okay.
into convolution of the Laplace transforms of individual
Okay.
states.
Okay, sir.
Okay.
Okay, thank you, sir.
Okay,
Okay.
sir. Thank you, sir, for clarification. Okay. So, differentiation property. Like, if we differentiate, it will be multiplied with s in the s plane. So if we differentiate by power n, so it will be like. So first we'll do in the time domain. If we do it in the time domain, it will be s power n times of x of s. So like if we do, this is a Laplace transform here. If we do the inverse Laplace transform from the s plane to a time domain, it will be like minus t whole power n x of t. And similarly, like I was discussing in the previous slide, right, regarding this property. So if we do the inverse Laplace transform for s plus a whole power minus n, inverse Laplace transform will be t to the power of n minus 1 e power minus at u of t by n minus 1 factorial. Usually we'll be forgetting over here, so in order to remember, we know that for s plus a, 1 by s plus a, it will be inverse Laplace transform will be e power minus at ut, right? So if we see here, it will be t, t, here it is minus 1, right, power. So minus 1, it will be getting 0. That's why here we won't be getting, here we'll be getting n minus 1. So 0 factorial will be 1. Not, so that's why we'll be getting t n minus 1 over here. And the final concept is initial value theorem and final value theorem. Initial and final value theorem. So it what initial value theorem tells, like usually before time t is equal to 0, we'll be assuming it as 0. So at time t is equal to 0, how the system, how we are getting the response, will be checking. Like that is what at initial value theorem at time t is equal to 0, how it is changing, it will be telling. So usually, so it will be x of 0 plus. So in order to get 0 plus, we'll be doing limit t tends to 0, x of 0. Sorry, x of t. And in the Laplace domain, it will be s tends to infinity. It will be reverse of this. S into x of s. This is the initial value theorem. For the final value theorem, here, what the final value theorem tells, like how the system is reaching, if when the time goes to infinity, how the value be. That is what final value theorem will be telling, how the output will be changing. So it will be x of infinity will be we'll be getting this x of infinity when t tends to infinity, x of t. So in the Laplace domain, it will be limit s tends to 0, s of x of s. So in time domain, if it is infinity, in the Laplace domain, it will be s tends to 0. Here, here also goes in the opposite way. This is clear, right? Hello, am I audible?
Yes, ma'am.
Yeah, till here, are you clear then?
Yes, ma'am.
Yes, ma'am.
Okay. Now we'll be moving on to the problems. So the first question is we have to find the Laplace transform of e power minus modulus of t. What is the Laplace transform we have to find? So how the graph will be? The graph will be like, it is a two-sided signal, right? For e power modulus of at or modulus of t. So we'll be applying the formula. So x of s is equal to integral minus infinity to infinity x of t e power minus st dt. So from minus infinity to infinity, e power modulus minus of modulus of t e power minus st dt. So from 0 to from minus infinity to 0, it will be e power t, because like it is I mean e power modulus of t is equal to e power t u of minus t plus e power minus t u of t. This is a formula. So it will be e power minus t. I mean, so here u of minus t is there, right? So it will be from minus infinity to 0, e power t e power minus st dt plus integral of 0 to infinity e power minus t e power minus st dt. So it will be e power 1 minus st dt integral 0 to infinity e power minus t 1 plus s dt. So if we do like e power 1 minus s t by 1 minus s, limits from minus infinity to 0 plus e power minus 1 plus s t by minus 1 plus s, limits from 0 to infinity. So if we substitute the limits, it will be 1 minus s. So e power 0 will be 1 minus e power 1 minus s into minus infinity, it will be, so since it will be e power minus infinity, it will be coming 0 here. So here it is minus, right? We'll be interchanging the limits over here. So it will be like 1 by 1 plus s into e power 0 will be 1 minus e power minus infinity will be 0. So it will be 1 by 1 minus s plus 1 by 1 plus s. So 1 minus s into 1 plus s. Here we'll be getting 2, right? So we have to see the zeros and poles over here. So zeros are the ones we'll be checking for the numerator, right? So here there are no zeros because there is no s polynomial. Only that's why we won't be having zeros, and we will be having poles here because we so poles will be s is equal to minus 1 here or plus 1 and s is equal to minus 1. So these will be the poles. Poles so poles will be located at minus 1 and 1. And zeros doesn't exist here. So because it is two-sided signal, we'll be having like a strip, right? like which is in the rectangular region. So this is how ROC for this looks like. So this is a stable signal because to tell the stability, it has to include this j omega axis. If it is included, means it is a stable signal, and it is a two-sided signal. If it is two-sided signal, means it will be non-causal, right? I mean, because it is not. I mean, it is existing in both when a t is greater than 0 and t is less than 0. So it is non-causal. It is stable because it is including a j omega axis. And causality, coming to causality, it is not causal. Is this question clear?
No,
Yes,
no, I
ma'am.
can't understand this. 1 minus s and 1 plus s. Please explain this.
So, okay, like what are the roots of this?
The plus 1 minus 1 I understood, but range ROC I not get it.
ROC range.
Yeah.
So, like if we see in the time domain, it is two-sided signal, right?
Yes, yes.
So, if it is two-sided means, like how will be the ROC? I have discussed here, right? If it is two-sided, it will be like a strip, right? Here.
Yes.
So that's why it will be like a rectangle shape. It will be like a strip. Between -1 and 1, it will be existing ROC. Uh,
Then causal and stable.
like causality means how will be telling the causality by. So if it j omega axis includes in the ROC, then it is stable.
Yes.
So here we are having j omega axis, right, in between the ROC.
Yes.
So it will be stable. Coming to the causality, like here, like in the time domain, it is a two-sided signal, right? Or like from the ROC, we can tell it is two-sided signal. If it is two-sided signal, means it is non-causal, right?
Yes, causal should be right sided, no?
Yeah, like causal should be right-sided. I mean, I am telling it is not causal.
Yes.
That's why I kept. I mean, okay, it is non-causal.
Yes, yes.
Now, did you get? Is my point clear?
Yes, ma'am. Yes. Yes, ma'am.
Okay.
Okay, a small addition here. Okay,
Okay, sir.
yeah, the same what Nanda said right now. So usually for causality, no, you can actually see the ROC, and if ROC is right-sided plane, right half plane, then it is causal. Okay, so here it is not the case, right? So it is not causal. For stability, that j omega axis, which is imaginary axis, should be in the ROC.
Sir, how we will take this? That 1 minus s greater than 0, 1 plus s less than 0. Uh, can you tell me please by
Yeah, so that is what it is discussed, right? So usually left side signals will have ROC to the left hand side, right?
Uh, yeah, you can see this like here
Yeah.
right sided and left
So
sided.
usually you see right-sided signal will have ROC to the right side, right of one vertical line, right?
Yes, yes.
And left-sided signals will have left side of one vertical line. If you
Yes.
have two-sided signals, which is like both left and right? So both, right? So both means it should actually be left of one straight line and also to the right of another straight line, which will form a strip like this, right?
Yes,
Got it?
sir. Yes, sir.
So yeah. So depending upon the signal, ROC changes. Or
Yes, sir.
calculated. Okay.
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 Sir.
Sorry. You are going to take problems, right, Lavanya?
Yes, sir.
If you don't mind, I have a couple of things that I wanted to say. I'm unable to sit for very long
Okay,
time.
sir. Would you like to
I'll
share the screen,
No, no,
sir?
no, no. I can't share also. I'll just tell few points to them.
Okay, sir. Carry on.
Yeah, so I don't have my laptop also. Okay. Hello all. Yeah. So firstly, I'm supposed to take the session, but unexpectedly I was down with the viral fever for the past 2 days. So even currently, also I'm gathering energy to talk to you guys. Okay. So let me finish what I wanted to talk about Laplace transforms and all. So basically, we will be providing you the formula sheet with the properties, right? But not the pairs. Okay, so we'll not be giving you a delta t signal will have Laplace transform 1 or u of t will have 1 by s with ROC real part of s greater than 0 or something like that. Okay, but you guys have to practice some problems and get used to this kind of pairs. Okay, so basic pairs only needed, not too many. But other properties and all we will give you. But the major thing is how do you use those properties is the big challenge. Okay, so for that also again Lavanya will anyway do some problems with you guys. Carefully do the problems and also solve some problems around the concept that were dealt in this particular session today. Okay, so that is one thing. And the next thing is there are few shortcuts for ROC. Now that you guys know how to plot this pole zero plot, right? So once you have a transfer function with you, if you have the pole zero plot with you, you can say something about ROC. So ROC will never contain any poles. Okay, so if you see that your transfer function has a pole at 2, so ROC will never have that line 2 within it. Okay, so ROC will never include any pole. So that you have to, I think she has mentioned, yeah. So poles will not be there. And coming to this causality and stability, you guys have to really practice a lot. Okay, so firstly, you should know how to plot the ROC. And once you plot the ROC, then you can easily conclude the stability and causality. Okay, so the stability, the only thing is you have to check is whether it has uh, Fourier transform or not. In other words, in simple words, from the graph, whether ROC includes j omega axis or not. If ROC has this imaginary axis, then the signal is stable. For causality, again, we know signal should be right-sided. If it is right-sided, ROC should be the right side. So the same thing here also. For causality, ROC should be the right half plane, right side half plane. Okay. So such a signal is such a signal is causal. Okay, and there is one thing that there are signals for which Laplace transform may not exist. And how do you say that? If there is no ROC, I think I have done it in previous live sessions. You can take a look at it. If there is no common ROC, so it's like if both sided signals here, there is some common ROC, right? So there is some common. Uh, so the left of 1 and right of -1 has some common region. So that is why ROC became like this. So if it had been like left of -1 and right of +1, then there would not be having any common ROC, which implies there is no Laplace transform. Okay, so there is no guarantee that any signal will have Laplace transform. Okay, so be careful about that. And don't buy hard properties. That's my point. But you should know how to use those properties very well. Yeah, initial value theorem and final value theorem. All this comes under properties only. We'll give the properties to you, but you should know how to use them. Yeah. That's all, guys. Yeah, thanks, Lavanya. You can continue.
Okay, sir. Thank you, sir.
All the very best for exam, guys. Hope you all do well.
Thank you, sir.
Thank you, sir.
Thank you, sir. The next problem which I'm going to discuss is about the pole zero plot. Question is like here the pole zero plot I'll be drawing now. So we have to find what is the transfer function from the pole zero plot. So so these are the zeros. And these are the poles I'm taking. J and minus 3j. J minus 2j, and it is at 1. And another pole is at 4. So, like, can you tell what is this point where the zero existing? Hello, am I audible?
-2 plus 3j.
Yeah, minus 2 plus 3j. How about this?
-2 minus 3j.
Minus 2 minus 3j, right? How about this?
-2 1 comma -2 2j.
Okay, good.
1 comma -2j.
And this is
4 comma 0.
4 comma 0, right?
Yes, ma'am.
So what I have told, like in order to find, so we have to find h of s here. So numerator polynomial by the denominator. So numerator is for
Zeros.
zeros, right? And denominator is for poles. So the polynomial goes like, so zeros are this, right? So it will be s minus of minus. So plus 2 minus 3j. You got this. For this, we are writing like this. Because s minus a, right? So I am changing the sign over here. Into another 0 is it s plus 2 plus 3j. This is a 0. Anywhere else are left zeros? No, right? Now let's go for the poles. The poles are at 3 points. So we'll be noting those points. S minus 1 is at 1 comma 2j. So s minus 1 minus 2j into s minus 1 plus 2j into s minus 4. Yeah, good. So we have to simplify this. So it will be like s plus 2 whole square. So if we take s plus 2 as a and 3j as b, it is in the form of a minus b into a plus b, which is a square minus b square. So minus of 3j whole square by, this is also same. So s minus 1 whole square minus 2j whole square into s minus 4. So it will be like s square s plus 2 whole square. So minus 9, j square is minus 1, right? As a result, we'll be getting plus over here Here also s plus s minus 1 whole square. Here we'll be getting, 2 to the 4 and j square is minus 1. So minus into minus plus. So you have to simplify this in order to get the polynomial. Will you do this calculation later? Hello.
Yes, ma'am. Yes, ma'am.
Yeah, you. So in order to get the polynomial, you have to do this calculation. So you understood the concept, right? Like how we are approaching this.
Yes, ma'am.
The other question is, so transfer function of a causal LTI system is given. So transfer function of causal LTI system is s plus 3 divided by s plus 4 whole to the power of 6. So now what we have to find is h of t we have to find. So we have to find the inverse Fourier transform they are asking, right? So how we'll be doing it is, so s plus 3 plus 1 minus 1 will be doing, because here we are having s plus 4, right? If we add this, it will be s plus 4, right? That's the reason I'm adding plus 1 and minus 1. So it will be like s plus 4 divided by s plus 4 whole to the power of 6 minus 1 by s plus 4 whole to the power of 6. This is clear, right?
Yes, ma'am.
So
Yes,
as a
ma'am.
result, what will be getting? 1 by s plus 4 whole to the power of 5 minus 1 s plus 4 whole to the power of 6. So this formula I have told in the one of the slide here. Here. So this formula I'm going to apply. So t to the power of 5 minus 1, 4 into e power minus, here a is 4, right? Here for s plus a, if you see here, for s plus a, here we are having minus a. So we will be getting as minus 4 40 ut by 4 factorial. Because n minus 1, because of n minus 1 factorial, I am applying the similar formula here. So it will be t power 5 e to the power of minus 40 u of t by 5 factorial. So this will be the answer. You understood?
Yes, ma'am.
Okay. So we'll be going for another problem then. Everyone clear, right?
Yes, ma'am. Clear.
Yes, ma'am. Clear, ma'am.
Okay, great. So now we have to, so now transfer function is given, which is h of s is equal to 2s square plus 3 divided by s square plus 5s plus 6. So input is given as x of t is equal to 3 times of u of t is a input to the system. So we have to find what will be the initial values and final values for the output. When the input is 3 of t, we have to find how will be the output, produced output, that is y of t, in the initial value and final value we have to find. So like what property you are getting into mind after seeing this? Can anyone tell?
HS equal to YS by XS.
Sorry?
YS.
HS. Okay. This is y of x by x of
Yes.
x.
Yes, ma'am.
What they asked here, they asked us to find the initial and final values, right? So here we have to use initial value theorem and final value theorem in order to find the output. Why we are doing this initial value and final value? In order to find how the system is gonna be in the initial time and the final time, right? So for x of s, how it will be? It is 3 times of u of t, like u of s. So for u of t, like in the standard pairs we have discussed, right? For u of t, it is 1 by s, where the real part of s is greater than 0. So it will be 3 by s. Okay. And h of s they have given. So we have to find y of 0 plus and y of infinity. What will be the value they are asking to find? So like y of 0 plus is equal to limit t tends to 0. Y of t is equal to limit s tends to infinity s into y of s. So y of s here is, what is y of s? Y of s is h of s into x of s, right? So we will be limit. So y of s is 3 by s into h of s is 2s square plus 3 by s square plus 5s plus 6. So it will be s into 3 by s into 2s square plus 3 by s square plus 5s plus 6. So here this s and this get cancelled. As a result, limit s tends to, sorry, here it is infinity, right? So like in the limits we would be knowing, right? Like if it is infinity, if we substitute infinity over here, entire term is getting infinity by infinity. We'll be taking common. So 3 is there here. 3 into s square into 2 plus 3 by s square divided by s square into 1 plus 5 by s plus 6 by s square. So this s square and this s square get cancelled. So we are left with 1 by s. So s tends to infinity, then 1 by s tends to 0, right? So instead of this place, we can substitute 0. So it will be 3 times into 2 into, so this gets 0 by, so this term and this term also gets 0 by 1. So initial value y of 0 plus will be 6. Am I clear? This. Hello.
Yes, ma'am. Clear.
So y of infinity now we'll be finding. So y of infinity will be limit s tends to 0, s of y of s, which will be equal to limit s tends to 0. So s into 3 by s into 2s square plus 3 by s square plus 5s plus 6. So this s and this s gets cancelled. If we substitute 0, it will be 3 times of this term. This 2s square will be 0 into 3 by, this gets 0, this gets 0 by 6. So we'll be getting 3 1 ja, 3 2 ja, 3 by 2 is the answer for y of infinity. That is final value. You understood this or any doubts? Hello?
No, ma'am, no doubt.
Understood. Understood,
Uh,
ma'am.
Okay.
Understood, ma'am.
Okay. Just a second. Okay. Will be so the other question is like they have given the relationship between input and output input and output as y of t is equal to x double dash of t convolved with delta of t. So we have to find y of s. Can anyone tell how to solve this? So like for convolution, how it will be convolution in the time domain it is. So how it will be in the S plane?
Multiplication.
Yeah. So it is derivative. I mean, this is double derivative, right? So so it will be d square x of t by dt square, right? So it will be s square into x of s. Am I right? For Laplace transform.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
So y of s will be s square into x of s multiplied with, for delta of t, what is the
It's one.
Fourier transform? It is 1,
One.
right?
One.
So
One
y
plus
of s will be, yeah, good. Y of s will be s square into x of s. This is the answer. And the other question, this is one question. So other question is like consider a stable LTI system. So with the h of t, so which is having impulse response h of t. So it is having pole which is located at s is equal to -3. And we have to find the pole of new system. So find the pole of new system which is having impulse response h1 of t is equal to e power 60 h of t. So we have to find the pole. So after seeing this, what do you remember? So like we have to find the new pole, right? This is the original one. For the original case, like S is situated at -3. Now we have to find the pole for this. So we have seen property right here. Like it is similar to this, right? What is a pole? Here it will be, we'll be adding with V, right? I mean, whatever the power is adding up here, we'll be adding with that. So x of t e power vt, Laplace transform is x of s minus v. So ROC for this is r plus real part of v And coming to the poles and zeros. So poles will be added up with that V, and zeros will be added up with V. So we are asking what is a pole. So
Ma'am, what is that R? ROC, R plus real part of E. What is that R?
R is region of convergence of actual X of S. RE is real part. Real
Okay,
part.
okay. Got it.
You understood now?
Got it, ma'am. Got it, ma'am.
Okay. So what they have told, pole is at it is at -3, right? -3 plus what is V over here? 6, right? If we compare both the things, it is 6 plus 6. So it is 3. So the new pole is located at 3. Any doubt in this?
No, ma'am.
No, ma'am.
Uh, Sorry? Hello?
Clear, ma'am.
So can I go ahead?
Yes, ma'am.
Yes, ma'am.
Okay. So here they have given LTI system. So in the differential form, so differential form is d square y of t by dt square plus 2 times of dy of t by dt minus 50 y of t is equal to 8 into d x of t by dt. So what we have to find is h of t we have to find. So this is the expression they have given us. Now we have to find impulse response of a system. That is h of t we have to find. So in this way we can't find. So that's the reason we'll be converting into Laplace transform. For differentiation, how it will be in the
S square into capital Y of S.
Square y of s.
yeah. Good.
2s
Yes,
y of
2S Y of S.
Yes.
Minus 15
minus
Y of
15
S.
y of s
Great.
8,
equals to
8S
8x
of S.
y of s.
X of S.
It
X
is
of
x of s here.
Sorry, ma'am.
So now we have to find the transfer function. That is h of s. H of s is y of
8
s divided by
X of
x
S.
of s, right? So
8 is by
8
X.
upon s square plus 2s minus 15.
it is
8
not 8 upon 8
8
is
is
Sorry, ma'am.
8 is by, you have to be careful, like you have to see regarding calculation as well. Like I think most of the people will be doing like a small minor mistake that can lead to incorrect at the end, right? You have to check these minor details as well. Okay. So s square plus 2s minus 15. Okay, you can tell, like I am telling where you will be going wrong. Hello.
yes,
Yes,
ma'am.
So if you fractionalize it,
S minus 3 S
after
plus 5.
good, s minus 3 s plus 5.
Partial
So
fractions.
yeah, we have to apply the partial fractions. So we'll be taking, we have to convert into partial fraction, right? So a by s minus 3 plus b by s plus 5. So you will do, if I tell like what will be the a and b, will you do calculation how it will be? So a will be 3 and b will be 5. Answer. Like here. or should I solve it? Hello, for partial
Ma'am,
fraction. Yeah. Hello. Yes,
individually
yes.
solve, ma'am, individually solve for if a question is given, if the system is stable, then find impulse response, and another question is if the system is causal, then find the then find the
You are
HT.
asking this question only, huh?
This in the question, this type of differential equation,
Okay.
individually the output will be different for causal and for stable.
Causal and stable.
Yeah.
So you mean you are telling is a system is causal or stable? You want to know? Is it like that?
No, ma'am.
No, ma'am.
Hmm.
In one previous
In the
paper,
mock, there is a question. Please refer to it, ma'am.
Which question?
The
Like
different
Uh,
two
like,
question is given, ma'am, for differential equation.
can you share me it?
I can tell you a differential equation.
Okay, I will write it then.
can I share, ma'am?
Yeah, or else let me finish this question or later you can share. Is that fine? After this
Okay,
question?
okay, okay.
Okay. Just we'll solve this question and you can share. We'll try to solve that. So it will be 8s. So s plus 5 plus b into 5 minus 3. So if s is equal to minus 5, then this gets 0. So minus 5 minus 3 is minus 8. So here minus minus get cancelled, 8 get cancelled. So b will be 5. And if s is equal to 3, so 8 into 3 is equal to a into 3 plus 5, 8. So this term gets 0. So a will be 8. Sorry. So a will be 8, right? Sorry, this 8 and this 8 get cancelled. Will be getting a is equal to 3. So h of s will be 3 by s minus 3 plus 5 by s plus 5, right? So if we do the inverse of this, we'll be getting as 3. So here it is minus 3, right? We'll be getting here minus e power 3t u of minus t plus, for s 1 by s plus a, it is e power minus 5t u of t. So this is the answer. Am I clear? Hello.
Yes, ma'am.
Yeah, now you can share me the screen. You can share. So Friday evening, what is it? Friday evening, I'm seeing the chat now.
Evening session, ma'am. Friday evening session.
Friday evening, there is no session.
The session for math, Friday evening.
And what does mean
That
by
is
allow here? So allow here is like passing the signal. I mean, uh, like the frequencies which are near, like low pass and high pass. You know low pass and high pass filters, right? Any idea?
Yes, ma'am.
Uh, in the low pass, it will be allowing the low frequency signals. It won't be it will be attenuating the high frequency signals, right? For low pass. I mean that's what I mean by allow and attenuated.
Okay,
Did
ma'am.
I clear your doubt, Sonali?
Yes, ma'am.
And the entire syllabus is from 1 to 12. Like it is entire syllabus.
Ma'am, will it be equally weighted? Not right.
So I mean equally weighted in the sense.
Like all 1 to 12 syllabus will get equal number of topics, questions.
S- so most of the thing, more I mean like it is more weight is after quiz 2. I mean it is. I mean that is also having uh a part, but more weight is from 9 to 12 will be there. I mean, if we take it is around 50 questions till 8 you can take, or and 50% will be 9 to 12 in that ratio.
Okay, ma'am.
I mean, since it is not the part of the quiz 2, I mean, quiz 1 and quiz 2 we are having this, right? I mean, so like, ma'am, don't we have property like multiplication? Like for this, sir have clarified, right,
Yeah, ma'am.
Nanda?
Sir clarified, ma'am.
Yeah. So other thing. So you are answering this, right?
Yes,
Here,
ma'am.
yeah, it is -2 by s square minus 1. Correct. After calculation, ROC, yeah, fine. Yes, yes. Any more things? Yeah, you can tell. Hello. Yeah, like Nanda, you are sharing the screen, right? Yeah, proceed.
In this question, ma'am, that is eighth sum. It is asked that to find the h of t, which is neither causal nor stable.
Is neither causal nor. Can you keep it into there, like chat box? 8 to 8, no? A single question. Is it?
No, this is the part of differential equation, that is LTI system. Third part.
I think this is connected to that, right? Is it?
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. Yeah, we will solve that then. Can you show me that question once again? So just a second. Okay. So
Okay.
can you tell me? I'll be writing d square. I mean,
d
like I
square
don't
y
have.
d square y minus dy
Okay. So here they have given input output relation.
uh, minus 2y equal to dx.
Just a second. D square y of t by dt square minus dy of t by dt 2y of t is equal to dx of t by dt. Okay. So like they have given like x of t and y of t as an input. So yeah, okay. Determine h of t. That's right. We have to determine h of t.
such
Right.
that it is neither causal nor stable.
Yeah, we'll do that then.
Ma'am, we need to choose the ROC, right? So we will get we need to choose the correct ROC so that it is neither causal nor stable. Like that only we
Yeah,
need
yeah,
to
yeah.
choose.
Yes. You have
Okay,
to
ma'am.
choose neither. I mean, for for the one axis, like it could be if it could be right sided or left sided, right? In which side, if it is following non, I mean, not stable means it should not be stable, right? So it should not include the x
J
axis.
omega.
I mean,
J
j
omega.
omega axis. So it has to be completely left sided signal.
Ma'am,
So
right
no,
side.
neither. Yeah, it could be okay. Can you stop sharing the screen? Uh, just a second. Even in the question, as it should be nor causal. I mean, neither causal and nor stable, right? So for the causality, I mean, it should be right sided signal, right? If it is causal means it is right sided, right? Signal. So they are telling it is it should not be causal, so it has to be left sided signal and not stable. I mean, for stability, j omega axis need to be included. As they're saying, it should not be included, so it has to be in this way or OC. Am I correct? Did you understand why ROC will be in this direction?
Yes, ma'am.
Because it should not be stable means it should not include j omega axis, and neither causal means, I mean, for causality exists for right sided, right? So if for suppose if it is in this way, here it is including this. Okay, for suppose if the j omega axis is here, if it is like this, it is right sided, it is causal, right? It should not be this case and this case, it should be this case, right?
Yes, ma'am.
Ma'am, if it is only stable, not causal,
Yeah, only stable, not causal means it should be like this. So j omega axis will be included. It is stable, right? Since it is including the j omega axis, right? This is j omega axis.
Could you please take an example?
Example, what to say? Can I, for more clarity, can I check and get back to you later
Yes, ma'am.
in the G space? Will
ma'am.
that work? Yeah.
I have another differential equation. Can you write
Okay.
please?
Okay.
D
Do we
square
need to
y
solve? Just 1 second. Uh, 1 second. Do I need to solve the question or is it fine? Like the previous question which you have told. Hello. You have showed me a question, right? Do I need to solve that or is this explanation clear for you? Can I go with the next question?
Ma'am,
Ma'am,
please
then
solve it.
what will be the output result? That is e to the power. If we take that the
Yet,
and
telling the question now. 1 second. Are you telling the question? Uh, yes, Soma Mandal.
yes, ma'am. d square yt dt square.
Uh, d square
Yt dt square
yt dt square
minus dyt dt minus 2yt
hmm.
equal to xt.
xt, yeah?
Yes, yes, only xt, only xt.
Only xt. This is another question, huh?
Yes,
No,
yes.
ma'am. No, ma'am. DGT of XT.
Yeah, there is differentiation is there, like I guess.
I mean, it is in the question.
Yes, ma'am. DGT of XT.
Like, are
Okay.
you? I mean, so Mandal, are you discussing about another question or the same question which we are discussing from
No, ma'am,
before?
this is another question.
Okay,
It
so
in
only
this
xt.
question it is given two separate question, that is, if the system is stable, find impulse response, and another is if the system is causal, find HT, find the impulse response. Two separate question.
Okay, okay. So x of s, y of s, s square y of s into y of s minus s y of s is equal to x of s, right? So h of s will be 1 by s square minus s minus 2. So minus 2 into 1. So it will be 1 by s plus, sorry, s minus 2, s plus 1, right?
Yes, ma'am. Yes, ma'am.
So zeros will be, so zeros, there are no zeros. No zeros. And the poles will be 2 and minus 1, right?
Yes.
So we have to plot the pole. One pole is minus 1, another pole is at 2. So for the stability, so if it has to be stable, means it. Uh, I think uh, if it is stable means ROC, for suppose there could be, we can assume few cases from this. One is completely left sided. If it is left sided signal means it is non causal because it is left sided and it is not stable, right? In this case,
Yes, ma'am.
if we take another case like this, then it will be right sided, so it will be causal, and since it is not including j omega axis, it will be not stable, right?
Ma'am. Yes, ma'am.
So we have to find the right part of that. In this case, you have to find h of t. Did you understand? Like for this, the second question.
Yes, ma'am.
Okay, coming to the first part. So for this, so in order to be stable, it has to include this, right? I mean, x of j omega.
Yes, ma'am.
J omega axis need to be included. So it will be stable and it will be two-sided signal. So if it is two-sided means it is not a causal.
Yes,
So
ma'am.
in this case, you have to find the h of t. So you, for the first question, This is a case. For the second question, this is a case.
Yes, ma'am.
I hope I clarified your doubt.
Yes, ma'am. But I want to see the result. E to the power.
So,
We'll write the answer.
so h of t. Okay, we have to do the fractional partial fractions. B by s plus 1. So it will be okay. One is equal to. So when if s is equal to minus 1, 1 will be b minus 3. So b will be this, right?
Yes, ma'am.
And a, if you substitute 2 here, so a will be 1 by 3. Am I correct? Am I correct? Or any mistakes? If a is, I mean,
No,
if
ma'am.
it is 2 means,
Yes, 1 by 3. Yes, ma'am. It is 1 by 3.
so it will be 1 by 3, 1 by s minus 2. Minus 1 by 3 by 1 minus s plus 1. So for this it will be, I mean what will be the answer? E power at u of minus t, right? So like for the stability, okay, this will be e power at u of t. So for the stability, they are asking.
Yes, ma'am.
In order to be stable, it has to be two-sided signal, right?
Yes, ma'am.
So like it has to be two-sided. So it has to be e power at u of minus t. This has to be e power minus at u of t, right? In this way.
Yes, ma'am.
So it will be 1 by 3 into e power 2t u of minus t minus 1 by 3 e power minus t u of t. Am I correct for first one?
Ma'am, it is taking minus from, answer is minus 1 by 3 to the power 2t u minus t.
Okay, one second. I'll check for 1 by s minus a. Just a minute. In the one of the question also we were solving, right? For 1 by
Yes, ma'am. That is 2025 Jan session.
s minus a, it is like for one question we were here also we were using minus, right? Here we are keeping minus here.
Ma'am, it is the formula, but why it is minus outside? Because
Here,
u minus
okay,
t
we'll
opposite side, no? I can't.
uh,
Reversal is
it
done by
will be
u minus.
opposite.
Why it is minus 3?
Minus 1 by 3 you are asking, no?
Yes, ma'am. Why it is minus 1 by 3? I can't understand that.
Okay, like we can, okay, if we do for this Laplace transform, it will be like integral minus into 0, minus is there, 1 by 3 e power 2t. Am I right?
Without
E power
minus
is
3, it is causal. Given answer causal.
Sorry.
Without minus. 1 by 3 e to
Okay.
the power 2q minus t ut 1 by 3 e to the power 2t ut minus 1 by 3 e to the power minus t ut is for causal, only for causal.
Come again. Come again.
Only for causal it is both are ut and 1 by 3 it is okay. For causal I understand, but I understood,
Okay.
but not
U of t
stable
for
is
both of the. For the stability, you are having the problem,
yeah,
right?
yeah, yes ma'am, yes ma'am. I can't understand the minus before 1 by 3.
Okay. So just a second. Like get back to you again with this, like why it is minus. Or like 1 second, like we'll do this. It has to be here, it is you are clear, right? It has to be two-sided.
Yes ma'am, it's clear, all clear.
So like it will be 1 by 3. Here it will be minus e power 2 minus st by 2 minus s. So since it is minus here, it will be minus infinity 0, right? So it will be like 1 by 3 into. So if we get the minus, if we substitute minus infinity here, can I get back to you why it is like that?
Yes ma'am, yes ma'am,
Uh,
yes ma'am.
I will keep in the G chat, okay?
Yes ma'am, okay, okay,
G space.
okay ma'am.
So any other questions? Any other questions?
Ma'am, I have one doubt, ma'am.
Yeah.
In h of s,